So then let's start it. So today we will talk about networks. Briefly, I will remind who am I. My name is Emre. I'm from Turkey. I was a backend engineer. Right now I'm a DevOps engineer, and also I'm doing software architecture. I have an experience with different type of companies, like 7, 8 years. And today we will talk about what is the network, what is IP addresses, and what is the network components. So I think already everybody heard the network before, right? Okay. So before starting everything, just say that we are not experts of these topics. We are just like doing our jobs for like a couple of years, and then we have some know-how about what these things works, but our information may be not updated. So it's better to check some stuff before starting something. So what is the network? Is anyone remember the LAN parties? Yeah. Yes, I think a couple of people remember these. So, and also it's interestingly, this picture is real, by the way. They actually do that. So before the internet, when we want to play the online games together or want to just do like some kind of online things, but since there is no internet, we were just like gathering around in some place, connecting computers, each other with physical cables, and play games or do LAN parties. So actually, when I say network, I'm talking about some computers connecting each other in some way. So if you do a LAN parties, it's also an example of the network. And also, right now, probably half of you connected to guest Wi-Fi. And this means that your computers are connecting each other somehow. So this is also a kind of network as well. And also, if you see the large scale, we all connected to internet, and the internet connected to different devices. So internet is also a network as well. And what are the IP addresses? So what are the IP addresses is just designated addresses in this network. And they are assigned by DHCP servers. So when you connect the network, they will assign you an IP addresses, or you will get an IP addresses. It's depends like how the network structure is, but it's basically your home address in the network. And also they are only valid in the network. Let's assume that we and a bunch of guys, we are doing a LAN party, and I have an address, I have an IP address in this LAN party. And a couple of you other people do a LAN party over there, and they also have an IP addresses. So since these two network is not connected each other, these IP addresses only valid inside the networks. And these IP addresses can be temporary. So every time your computer connects a network, your IP addresses may change, or you may use a static IP addresses, and your IP address may be the same always. And what are the subnets? So we talk about the networks, and let's imagine that we have thousands servers in the same network. It will be catastrophic, right? Like all of the devices like talking each other. So that's why we are making network the small pieces. We are making a subnetworks. For example, we can create a subnetwork for finance division and engineering division. And then like the finance computers can be in this network, and then the engineering computers can be this network. And then if somebody in engineering network want to go to the finance network, they can use something named gateway to jump one network to other. But the thing is, we are just like grouping IP addresses and making small bubbles for computers to interact fastly.
Does the subnet correspond to like .1 or something like that?
Oh, I will explain this in next slides. It can be or it cannot be. It depends. I will explain later. And some of the subnet use cases, especially in the cloud, when we are managing multi-server companies, we usually have some type of network layering, like Bastion, DMZ, local. So, for example, if we have a private instance like a database, we want to make this database is not accessible from outside, or we have sometimes we have some private resources to hide it. So we usually in startups we usually have two type of networks. One is a public network, one is private network. And in the private network, we usually deploy private resources like databases. In public networks, we usually deploy like a front-end applications or API gateways or load balancer, this kind of stuff. And also, we can put firewalls between subnets and make sure that no one from the internet can directly access this database without jumping in public subnets. And while explaining the IP ranges, we have some standard called CIDR blocks. So I don't want to explain detailedly because there's a little bit mathematics in it, and I don't want to make everybody sleepy this morning. So, but you can think that when I'm explaining an IP range, I can say that, hey, 10, 10, 1, 0, and then 24. And this means this is an IP range. So this is 256 IP address IP range. And I can assign this to a subnet, and I say that, hey, subnet 1 is starting from 10, 10, 1, 0 to 10, 10, 1, 256. So or I can give a bigger range to a subnet, but usually we don't want to give uh, a bigger IP range to a subnet than we actually need it, because uh, if we are planning to have a couple of instances, we usually just give a couple of IP addresses to subnet for managing them easy. And also for debugging it or like looking the networking log, if you just give private IP addresses starting from 10, 10, 100, and then the public ones starting from 10, 10, 1, it's usually more human readable. As I told you, I will not explain the details, but you can say that CIDR notation is helping you to understand and give an IP range to do this kind of systems. Hopefully, this will answer your question. And also, we have gateways. So what are the gateways? Let's say that I have a network over there, and you guys have another network over there, and we want to talk each other. We want these two networks to connect to each other. So, but can they just connect? We say that the IP addresses are only valid inside the network, right? So my IP address is, let's say, 1, 2, 3, 4 in this network. But other network, maybe there is some other guy in the IP address is 1, 2, 3, 4. So how we talk each other, how we connect each other. So we are putting gateways. These gateways connects two networks together and then help you to communicate by these gateways. And most common example is in your home networks. You have your computers, phones, Apple TVs, and then you are connecting to internet, right? Internet is actually a group of network, a bigger network than your home network. So you also have a gateways. Everybody has a gateways, and we call this routers or modems. So this is connecting your local network to internet network. Or let's imagine that we have a network in Korea office, and also we have a network in LA office. So we are connecting these networks together, and then uh, the engineering division in Korea can access the finance division in LA. And also we have not gateways. Actually, the gateway is like general concept of like connecting these two networks, and there is a different type of the gateways. One of them is not gateways. We are using not gateways in the cloud, especially uh, like last couple of years since the serverless technology is really valid technology these days. So my personal experience, we are establishing more NOT gateways than a couple years ago. What NOT gateways do is actually it's also connecting one network to the other, but the main difference is NOT gateway is only one way. So let's imagine that we have a network, and inside of the network, this is a private network, and this private network we have a bunch of servers, and these servers totally isolated by the internet because of the security reasons. So, but these servers has to be updated. So these servers needs the internet connection. Not working? I, I have no idea. Is it not working? Lorem ipsum? No. Lorem ipsum? Okay. I think it's working, right? Yeah. So these NOT gateways is actually a type of gateways, but it's one way. Let's imagine that you have a private external network which has a bunch of uh, private databases which has a super important data in it. So you don't want this network to publicly accessible, but also you want these servers to update each other or can connect the external resources. So you just put a NOT gateway, and when your servers inside of this private network want to connect to the other servers in the public internet or in other networks, they can just jump on the NOT gateway and access to the other side. So this is a definition of the NOT gateway. And most important use case in these days, so as you all know, there's a serverless instances from the cloud providers, and these serverless instances does not have static IP addresses. It is technically not possible to give them a static IP addresses in most cases. But if you're doing an application with a corporate companies like banks, insurance companies, they all ask you that, hey, give me your IP address and I will add to my firewall. So when you send me a request, I will let you in, but the other people from the public internet, I will not let them in. So in these cases, the customers you are dealing with will ask you, hey, give me your IP address. But you say that, oh, no, we are using a serverless and you cannot give the IP address. This exact thing that happened. I think 6 years ago, we were running a startup with using other functions, and then we don't have a IP address because everything is like, yes, of course we have IP address, but it's changing always. We don't know what is it. And then we just sell thousands of dollars services to an insurance company. And the next day they ask us, hey, give your IP address, and we couldn't give them. And then we just built a bunch of NOT gateways overnight. And the next day we are able to jump our private service outside with NOT gateways. And also routing. But before starting routing, I want to ask if you guys have a questions.
Then can we create our private gateways using home routers?
I'm not sure if every router can do that. I mean, I'm not sure if they can do that physically, but technically, if you have a router with ability to establish a NAT gateway, yes, technically you can do that.
And then access to the internet, and we can uh, publish our website to our phone, computer.
Well, actually, since the NAT gateways work only one way, this means that if you have a NAT gate between two networks, let's say private network and public network, in private network, you can just send a request to the outside. So in your home, you can access to the internet, but somebody in the internet cannot access you because this is a one way. Yeah, you're welcome.
What's the difference between a router and a gateway?
Actually, the router is a type of gateway. So, but usually the routers are established as if you're using like a home router, home modem, they usually have some kind of softwares for related with your ISP providers. So they're kind of specialized. Uh, but I'm not sure if the case in Korea is the similar or not, but they're actually the same thing in general perspective.
The server, for example, in support of AWS.
Yeah.
They need to be that packet.
They can give you a static IP address. It is possible, but also they may not give you. Like it's depend of the service, and usually the cloud providers, if they give you a static IP address, they will charge you. In AWS, as I remember, it is $6 per IP address if you get a static IP address. And if you run an EC2 instance or virtual machine in DigitalOcean, it is possible to get IP address. But if you run a Lambda function or if you run a ECS instance or if you run Azure functions, it's not always possible to get a static IP address.
Way to bypass this is you can just
Maybe have a proxy server and you just
Yeah. Yeah, yeah.
Shouldn't give your IP address to the other services because they can DDoS you. I mean,
Well,
it's not safe. Or,
well, actually, like let's imagine that there is a 200 servers in one network, and this network is connected outside by a NAT gateway. So when the server A sends a request to outside network, the IP address this server will use, like I mean, the public IP address will the same IP address with the NAT gateway. And also, if a server B sends a request to the external public network, also the public IP address will be the same. So, and also this is a good practice because let's imagine that you have a 200 servers and the AWS charge you $6 per IP address. So if you have a, like, it's kind of proxy. So if you have a NAT gateway and if you have only one IP address, you just pay $6, but your 200 devices can connect to the internet via using this gateway.
no, I mean, if your 200 devices connected to one IP address and this IP address is static and like it's served
Yeah.
as a proxy,
Yeah.
You can have
Well,
one static IP address.
In the cloud providers, we usually get these services from cloud providers. So when I deploy a NAT gateway in AWS, AWS is the responsible of the health of that IP address or that physical NAT gateway device. So I am never worried about that they DDoS to AWS or Azure and they cause a harm. Any other questions? Okay, so routers. Okay, let's imagine that we have a couple of subnets and we have a couple of gateways, like internet gateways. and NAT gateways. And we need the, like these guys have to talk each other, right? So we need some kind of mechanism to make them talk, because subnet A does not know that what is subnet B, and subnet B does not know that what is happening in subnet A. So that's why we have a devices named routers, and this router devices helps this combination to work. And how they do that? They use routing tables. So for example, in this example, we have a gateway. This is a NAT gateway. This is not an internet gateway. By the way, internet gateway and NAT gateway, the difference is NAT gateway is only one way, just go out. Internet gateway is also, people can outside also come in as well. So it's just the internet gateway is just basically the same thing with your home routers. And in these routing tables, I'm defining a destination. I'm saying that, hey, if the IP address on this range, just go to this target. If the IP address coming from this range, just go to this target. So you can think that this is like highways in your network. And the router and these route tables just do this for you. We have two external private subnets, which has or servers in it or databases in it. And also we have some internal zones, which is public zones that or load balancers and API gateways are running. And in this table, there's actually something wrong. And I want you guys to find what is wrong, what is missing in this network. Let's imagine that I'm trying to host a mobile application, and this mobile application will send requests to the backend. And backend APIs has to process this. But this mobile application is on the outside of the network. You guys see the problem?
Yes, the internet gateway is missing.
Internet gateway is missing. So this is actually the mistake I do a couple of weeks ago. I deployed this infrastructure in AWS for one of my clients, and then they were not able to access their service from outside because, as you can see, there's only a dev gateway, and this dev gateway is a NAT gateway. So there is no way from outside to coming here. Like the servers inside, they can just freely go outside. But as you can see, the public gateways, the public subnets are not connected to internet. Yeah, like this was like a funny mistake I do a couple of weeks ago. So I just want to show you guys. And access control lists, ACLs. So what is the ACLs? ACLs is actually some security rules. You can say that, hey, this subnet or this IP address can access the other network or other IP address in using this port. So this is actually like a kind of firewall, but it's not technically, but this is some kind of definitions of who can access what in switch base. So for example, there is an administrator PC here. And as you guys can see, this can go to the internet, go to the gateway and access the file server, but these users not, because the ACL rule is prohibits these users to go this way. And also we have firewalls, which is a similar concept, but this firewalls is usually between some subnets or between the API gateway and subnets or between some machine, like some server, to some subnet. And these are usually locally managed. And these usually not like a general network rule, but it's a rule for going this spot to the other spot. And if you look the difference between that, the ACLs are more basics and they are stateless, and also the firewalls are stateful and more advanced. And how we operate these firewalls, we have a rule set, and we say that, hey, if somebody coming from this IP address to uh, and if someone coming from this IP address, just allow them or just block them, or you can say that if this IP range is coming from this port, block them or allow them. And also some smart firewalls these days has also some kind of AI supports, and you can say that, hey, if uh, a traffic coming which is suspicious, just block it. But in ACS, you just say if this dude is coming from here and try to access here, block this. And also, there's a really smart thing people do these days. In AWS, there is some kind of firewall services, and they are selling a block IP lists. For example, they just go and they just like know that a couple of million IP addresses from a Azure provider, or they know that all of the DigitalOcean IP addresses, and they just make a package, and then they say, hey, do you want bots to not interact with your website? Just add these IP addresses in your block list, and if somebody from the DigitalOcean network come to your network, this means that it's a server, it's a not human being, it's a machine, it's a software coming to this IP address. You can just block it. And the people start selling these IP lists, or they are like analyzing the traffic, they are analyzing the patterns. For example, if an IP address, like if someone sending the exactly same request a couple of million times in a 1 hour, they just say, since they are stateful, they already have a record of what happened with this IP address before. And they say, oh, this dude is just coming too often, let's block it. And then they can decide to block it. So the firewalls are a little bit more complex than ACLs, and ACLs are more like a network rule sets. Any question?
Like you can block the IP addresses or the copy,
And then we can block IP addresses that copying our using our server. Uh, for example, not allowed, not included in course. Yeah. Right.
Well, yes, but you cannot always use course. Like, let's say that you have a public API. You are a Binance.com and you have a public API, and you're allowing different people to connect your system, but you don't want some traffic. Also, the one of the cases, sometimes, like in some cases, I'm not sure if it's the smartest way, but I was working in a startup company in Finland, and they have a local product, and only people in Finland can use this product. So if somebody access their website from US, they cannot use it. So they asked me to block the all traffic outside of Finland, because they also had some kind of bot attacks. So they were like having some DDoS issues, and they blocked all traffic outside of Finland, and they prevented DDoS. I'm not sure this is the smartest way, but sometimes you want to block some certain countries geographically. Let's say that because of the legal reasons, you cannot work with United States. So you don't want any United States customers to come to your website and purchase something because of some legal reasons. You can just block the whole country
And one more question. In network, we can only send outgoing requests. Yeah.
Well, if you have a only NAT gateway, like the
Yeah.
example I showed before, yes, correct. But
And
if you have an internet gateway, also the people from outside can come to your network as well.
so in ACL's network, we can get only incoming requests. Yeah. From picture, I understand.
Well, no, actually, all type of network movements in the like in ACL, you can just manage all type of network movements, like one server going, like one server to other server inside your network. You can just manage that, or somebody coming from outside via jumping a proxy server or internet gateway. You can also manage that.
Yeah. Can you show ACL?
This one.
Yeah.
Well, this is just an example. Yes, this is maybe a missing example.
No, in this case, we can control which ACL, right?
Yeah.
Thank you.
Yeah, you're welcome. There's a one question over there.
So in the case of the service which is selling a list of IP addresses that you should block, because that might be a bot, then what if the bot is like always changing its IP address? Then is that going to be useful?
Well, so this kind of services, you just like pay as a subscription fee. Like you are just paying like $10 per month, and they say that they will always update their lists. And also like the kind of the products I tell you, you are actually not have the list of the IP address. They just connect to your firewall and they just check the IP address if it's in their network or not, and what is the level, what is the level of the issue. Like, for example, if it's just a bot, maybe you want them to enter, but if they are a known hacker group from some other country, maybe you don't want them at all.
So the list of IP addresses is like continuously being updated minute by minute.
Well, like there's some companies who work is doing that, and you can purchase this from these companies. And also there's some other companies like Cloudflare. And for example, Cloudflare says that since they are like the most of the DNS service in the internet is actually running on the Cloudflare. So Cloudflare has a really big data about the like which IP address is harmful and which IP address is not. And also Cloudflare also sell you as a service exchange up to $200 per month. Yeah. To mic off again. Maybe we start with charge them. Lorem ipsum. Hello, hello. Another question? Okay. So yeah, port forwarding. Let's imagine that we want to run a Minecraft server in our house. So the Minecraft server using some special port. And since our router in the house is not allowing incoming traffic in this port because it's obviously a security reason, we want to allow some ports from outside to only a specific machine. We can say that, hey, you can just come in and we are just allowing this traffic to all of our servers. Or we can say that, hey, if there is someone coming from outside of the network with the port of this Minecraft server, we can forward this traffic to a specific server inside our network. Like you can imagine that you just have a separate computer in your house, and you want to play a Minecraft with your friends, so you just set up it and you just plug somewhere, and you just assign a static IP address in your network, and you also purchase a static IP address from your internet provider, and you just add some kind of routing rule in your router, which is allowing this specific port and forwarding this to your specific instance inside. And we are calling this thing as port forwarding. Questions? Okay. So this is the end of my presentation. Today we cover some network components, and the next session is also mine. We finish 15 minutes earlier than planned, I guess. So we can have a 5 minutes break and then continue with the next session. Okay, thank you.